Now we are going to see about the support vector machine in artificial intelligence machine learning algorithm. As we all know that is a machine learning classification algorithm that is it's also called as SVM. And we see about the introduction of support vector machine. It is a supervised machine learning algorithm that is used for classification and regression task, and it works by finding the optimal hyperplane that separates different classes of data with maximum margin. There are many features that is available in here. That is the supervised learning algorithm used for binary and multi-class classification. It also can also perform a regression, that is SVR, and it is effective in high dimensional data sets. Before moving on to that, we have to know about the important terms that are used in SVM. That is hyperplane, margin, and support vectors and objective. So hyperplane is that a decision boundary that separates the different classes that comes in the hyperplane. If it is a margin, the distance between the hyperplane and the nearest data points. The support vector is the closest data points to the hyperplane that determines the position. So objective is that the largest possible points, will be calling it as objective. And support vector machine works with the steps. That is, first we have to collect the training data, and we have to plot the data points in feature space, and we have to find the support vectors, and we have to compute the optimal hyperplane, and we have to classify the new data based on which side of the hyperplane it falls. The workflow will be the first we have to get the training data and the feature space and the hyperplane. After that, the final there should be a prediction. And hyperplane and margin is that before moving on to it in detail, we must know about what is hyperplane. A hyperplane, it is a line that is maybe a 2D or it may be 3D, that which it is used to separate the different classes. So the margin is that it is the distance between the hyperplane and the nearest support vectors. So why we have to have the margin as the maximum. So for better classification accuracy and for better generalization and less chance of overfitting. And next we'll be going on to the kernel function. That is, before moving on to that, we have to know about what is kernel. Kernel function transforms data into a higher dimensional space so that non-linearly separable data can be classified. There are different types of kernels, are there: linear kernel, polynomial kernel, radial basis function kernel, and sigmoidal kernel. So the types linear kernel is that it is used when the data is linearly separable. We will be using this type of kernel, and when it is a curved decision boundaries, we'll be using the polynomial kernels. And actually, most commonly used kernel is radial basis function, and sigmoidal kernel will be work similarly to the neural networks. And the applications of real world applications of SVM is that email spam filtering they'll be using for face recognition, image classification, text categorization, handwriting recognition, medical diagnosis, bioinformatics, fraud detection, customer segmentation, and for these things, real world applications, we'll be using the SVM. Thank you all.